Imagine waking up tomorrow only to discover that Earth is no longer safe. Our oceans are disappearing, the atmosphere is collapsing, and humanity has only one option left: leave. Not for Mars, not for the Moon, but for another star. A place so distant that even our fastest spacecraft would need tens of thousands of years just to arrive. Yet among the billions of worlds scattered across our galaxy, one planet stands out. Not because we know it's beautiful, not because we've seen oceans or forests. In fact, we've never even seen its surface, but because it may be the closest place where humanity could one day attempt to build a new home. A world orbiting the nearest star beyond our sun. A planet scientists call Proxima Centauri b. For years, this mysterious world has been described as Earth's closest cousin, a planet where the so-called habitable zone, a place where liquid water might exist. Some headlines even called it Earth 2.0. But here's the problem. Almost everything you've heard about Proxima b is only part of the story. Because hidden behind the exciting headlines lies one of the most hostile environments we've ever discovered. A planet where the sky may never change, where deadly radiation storms can strike without warning, and where survival itself could become the greatest challenge humanity has ever faced. So tonight, we're leaving the solar system, traveling farther than any human has ever gone. Not to imagine science fiction, but to explore what modern science actually tells us about the closest alien world we've ever found. And by the end of this journey, you may begin to wonder whether Proxima b is humanity's greatest opportunity or our greatest mistake. Space has a strange way of changing our sense of distance. On Earth, driving 100 kilometers feels like a long trip. Flying across an ocean seems enormous. But the moment you look beyond our solar system, those distances become almost meaningless. Light, the fastest thing in the universe, travels nearly 300,000 kilometers every second. In a single second, light could circle Earth more than 7 times. It reaches the Moon in just over 1 second, the Sun in about 8 minutes. Now imagine letting that same beam of light travel, not for minutes, not for days, not even for years, but continuously through the darkness of space. For more than 4 years. Only then would it finally arrive at Proxima Centauri, the closest star beyond our own. At first, 4 light years doesn't sound impossible, but numbers in astronomy can be deceiving. If you converted that distance into kilometers, the result would stretch into tens of trillions, a number so enormous that the human brain struggles to picture it. Let's put it another way. Voyager 1, the fastest spacecraft ever sent beyond our solar system, has been traveling through space since 1977. After nearly half a century, it has only traveled a tiny fraction of the distance needed to reach Proxima Centauri. If we aimed Voyager directly toward that star today, it wouldn't arrive next century, or the century after that. In fact, its journey would take roughly 70,000 years. Think about that. When Voyager would finally arrive, every nation on Earth, every city, every language we speak today would almost certainly be gone. Human civilization itself could become unrecognizable. And yet, despite this unimaginable distance, Proxima Centauri is still our closest stellar neighbor. Everything else lies even farther away. That simple fact makes this tiny red star
one of the most important objects in modern astronomy. Because if humanity ever becomes an interstellar civilization, our first destination will almost certainly begin here. But what exactly is Proxima Centauri? Is it another sun? Not quite. Compared with our star, Proxima is surprisingly small. It's only about 1/8 the size of the sun and shines with less than 1% of its brightness. If our sun were a giant lighthouse illuminating the solar system, Proxima would resemble a glowing campfire, visible only from nearby. Its light is dim. Its heat is weak. And yet, because it burns fuel incredibly slowly, this tiny star could survive for trillions of years, long after our own sun has disappeared, long after Earth itself may no longer exist. Orbiting this ancient star, astronomers discovered something extraordinary. A rocky planet, roughly the size of Earth, close enough to receive the right amount of warmth, where liquid water might be possible. At first glance, it sounded like the greatest discovery of the century. But science rarely rewards first impressions, because as researchers continued studying Proxima b, they realized this planet might be hiding secrets far stranger and far more dangerous than anyone expected. And the biggest surprise wasn't the planet itself. It was how we found it. Because unlike every world you've ever seen in a science documentary, Proxima b has never actually been photographed. Imagine someone tells you they've discovered an island in the middle of the ocean. An island no one has ever photographed. No satellite has seen it. No ship has landed there. No airplane has flown overhead. Yet somehow, they're absolutely certain it exists. It sounds impossible, but that's exactly how humanity discovered Proxima Centauri b. Unlike the planets in our own solar system, this world is simply too far away to photograph directly. Even our most powerful telescopes can't separate the planet from the overwhelming glow of its tiny parent star. Trying to see Proxima b is like standing thousands of kilometers away and attempting to photograph a single grain of sand while a powerful lighthouse shines directly behind it. The planet completely disappears in the star's light. So instead of searching for the planet, astronomers decided to watch something else.
The star itself. Because every planet, no matter how small, pulls on its star with gravity. Most people imagine planets orbiting motionless stars. But that's not how the universe works. Gravity is always a two-way conversation. As a planet circles its star, the star also moves. Not by much, just enough to leave behind an invisible clue. Imagine two ice skaters holding hands. One is much heavier than the other. The smaller skater spins in a wide circle. The larger one barely moves. But they both orbit the same invisible center. Stars and planets behave in exactly the same way. Every 11 days, Proxima b gently tugs its star toward us, then away again, back and forth, over and over.
The movement is unbelievably small, only a few kilometers per hour, less than the speed of a city bicycle. Yet across 4 light years of empty space, scientists somehow measured it. How? By studying light. When a star moves toward Earth, its light becomes ever so slightly bluer. When it moves away, the light shifts ever so slightly toward red. The difference is so tiny that no human eye could ever notice it. Only incredibly sensitive instruments, capable of measuring changes smaller than 1 part in a billion, can detect it. Night after night, astronomers observed Proxima Centauri. Not for days, not for weeks, years, patiently collecting thousands of measurements. Most nights, they found nothing. Sometimes the star appeared to wobble, only for scientists to realize it was caused by violent activity on the star itself. Other signals vanished completely.
More than once, researchers believed they had found a planet, only to discover they had been fooled by the star's own behavior. Finding Proxima b wasn't a single moment of discovery. It was years of eliminating every possible mistake. Then, one signal refused to disappear. Every 11.2 Earth days, the same tiny pattern returned. Again, again, and again. There was only one explanation. Something massive was orbiting the nearest star beyond our sun. A new world hidden in the darkness. When astronomers announced the discovery in 2016, it instantly became one of the most important planetary discoveries in history. But while the headlines celebrated, scientists remained cautious, because discovering a planet is very different from understanding it. Think of hearing footsteps behind a closed door. You know someone is there. You can even estimate how heavy they are, but you have no idea what they look like. That's our relationship with Proxima b. We know it exists.
We know roughly how massive it is. We know how long its year lasts. And we know how close it orbits its star. But almost everything else remains hidden. We don't know what color its surface is. We don't know whether mountains rise above its horizon. We don't know whether rivers have ever flowed there, or if the planet has already become a frozen desert or a lifeless wasteland. Even its atmosphere, if it still has one, remains one of astronomy's greatest mysteries. In many ways, Proxima b isn't a destination. It's a question waiting for future generations to answer. And that mystery only becomes deeper because of where the planet lives. Unlike Earth, which comfortably circles a relatively calm yellow star, Proxima b hugs a completely different kind of sun, a red dwarf. Smaller, cooler, far dimmer.
But also far more unpredictable. To receive enough warmth for liquid water, the planet has to orbit incredibly close to its star, closer than Mercury is to our sun. At first, that sounds like good news. Closer means warmer. Closer means more light. Closer means a better chance for life. But in space, every advantage comes with a price. Because moving so close to its star doesn't simply change the planet's temperature. It changes the entire way the planet lives. Its days, its nights, its climate, its oceans, even time itself. The very gravity that keeps Proxima b comfortably warm may have permanently locked one side of the planet toward its star, creating a world where sunrise never happens, and sunset is nothing more than a forgotten idea. And that's where our journey becomes truly strange, because stepping onto Proxima b would feel nothing like stepping onto another Earth. It would feel like arriving on an entirely different kind of world. Close your eyes and imagine the impossible. After decades of travel through the darkness between stars, your spacecraft finally slows down. Outside the window, a deep crimson star glows against the endless black of space. This isn't our sun. This is Proxima Centauri, the closest star beyond our solar system. As your engines fire one last time, the spacecraft begins its descent
Clouds, if they exist, drift beneath you. Dark continents stretch across the horizon. And then, for the first time in human history, your boots touch the surface of another star system. The moment should feel triumphant. Instead, it feels unsettling because something is immediately wrong.
You look around, waiting for the sun to move. Minutes pass. Nothing changes. An hour later, the shadows haven't shifted. You check your watch. Another hour. Still nothing. The giant crimson star remains frozen in exactly the same place. No sunrise, no afternoon, no sunset. Just a silent red sky that never changes. At first, you might think time itself has stopped, but it hasn't. The planet has. Back on Earth, our world spins once every 24 hours. That steady rotation creates day and night. It's so familiar, we rarely stop to think about it. But Proxima b lives under completely different rules. Because it orbits extremely close to its star, gravity has likely slowed its rotation until the planet became tidally locked. This strange process happens throughout the universe. Our own moon is a perfect example. Have you ever noticed we always see the same side of the moon? That's because its rotation matches its orbit around Earth. One face always points toward us. The other remained hidden from human eyes for all of history, until spacecraft finally flew around it. Now, imagine the same thing happening, not to a moon, but to an entire planet. One side always faces the star. The other never does. Forever. Let's begin on the bright side. If you stood directly beneath Proxima Centauri, the star would dominate the sky. Not because it's larger than our sun, but because you're incredibly close to it. The red disk would appear enormous, several times wider than the sun looks from Earth. Yet, strangely, it wouldn't feel overwhelmingly bright. Proxima is a cool red dwarf. It produces far less visible light than our sun. Instead of a brilliant blue sky, the landscape would be bathed in deep shades of orange, red, and copper. Everything around you would resemble the final moments of sunset. Except, sunset never comes. Imagine living your entire life under permanent evening light. There would be no mornings, no golden sunrise, no colorful dusk. Only one endless afternoon, stretching across centuries. Your shadow would always point in the same direction. Buildings would never receive sunlight from another angle. If trees somehow existed, they would grow beneath a sky that never changed. Time would lose one of its oldest meanings. Without sunrise or sunset, how would your brain even know when a new day begins? Now, walk away from the light. Kilometer after kilometer, the crimson glow fades. The air becomes colder, the landscape darker. Eventually, you cross an invisible boundary. And suddenly, the star disappears forever. You have entered the night side, a place where daylight has never existed. The sky above isn't blue, it's black. Always. Thousands of stars shine overhead, uninterrupted by sunlight. The Milky Way stretches from one horizon to the other, more brilliant than anything ever seen from Earth. But beauty comes with a price. Without
constant heating from the star, temperatures here could plunge hundreds of degrees below freezing. Water would become solid ice. Carbon dioxide might freeze directly onto the ground. Towering glaciers could cover entire continents. Any unprotected human would survive only moments. Not because of predators, not because of storms, but because the planet itself has become an endless, frozen wilderness.
So, if one side is too hot and the other too cold, is there anywhere life could survive? Possibly. Between the eternal day and the eternal night lies a narrow band circling the entire planet. Astronomers often call it the terminator zone. Here, the star would always sit just above the horizon, never rising, never setting. Temperatures might remain surprisingly moderate, not scorching, not frozen, just balanced. If Proxima b still possesses a thick atmosphere, powerful winds could transport heat from the bright side toward the dark side. That circulation might prevent the planet from becoming completely uninhabitable. In fact, this narrow twilight region could become the only place where future human colonies might exist. Imagine cities stretching across an endless ring around the planet. Every home facing the same eternal sunset. Every window overlooking the same crimson horizon. No calendars based on seasons. No clocks measuring sunrise. Only artificial time, created by people who refused to let another world rewrite what it means to live. It sounds almost peaceful. A civilization balanced perfectly between light and darkness. But appearances can be dangerously misleading. Because the greatest threat on Proxima b isn't the frozen night. It isn't the endless daylight. It's the star itself. At any moment, without warning, that calm red sun can explode with astonishing violence. A peaceful sky can become a deadly storm in minutes. Invisible radiation races toward the planet, powerful enough to strip away atmospheres, powerful enough to sterilize entire landscapes, powerful enough to turn humanity's greatest dream into its greatest disaster. And if those eruptions happen often enough, one terrifying question begins to emerge. Could Proxima b have already lost the very thing every human needs to survive? Its atmosphere. That answer may determine whether this alien world is a future home or simply another beautiful illusion waiting in the darkness.
Imagine it's no longer the year 2026, or 2126, or even 2326. Human civilization has survived for centuries. Technology has transformed beyond anything we recognize today. And after generations of dreaming, humanity finally accomplishes the impossible. Not another moon landing, not another Mars mission, but something far greater. The first permanent human settlement around another star. Millions of people watch from Earth as history unfolds. A small spacecraft descends through an alien sky. Its engines slowly fade. Dust rises beneath its landing legs. Then, for the very first time, a human being steps onto a world orbiting another sun. Not as a visitor, but as a settler. At that moment, human history changes forever. Because humanity is no longer a species confined to one star. We become an interstellar civilization. But surviving isn't only about food or oxygen. It's about the human mind. Imagine spending your entire life knowing you can never go home. A message sent to Earth takes more than 4 years to arrive. The reply? Another 4 years. Every conversation with your family is separated by nearly a decade. By the time your parents receive your birthday message, you've already celebrated 4 more birthdays. If someone you love becomes sick, there's nothing you can do. If a child is born on Earth, they may be an adult before you ever hear their first words. Distance isn't measured only in kilometers. Sometimes it's measured in time. For the first settlers, loneliness could become as dangerous as radiation. Now imagine thousands of years passing. Generation after generation, people continue living beneath Proxima Centauri's crimson sky. Children are born. Families grow. Cultures evolve. Language begins to change. Technology develops independently. Eventually, the descendants of those first explorers may no longer think of themselves as Earthlings. They may call Proxima b home. Evolution could begin shaping them in unexpected ways. Perhaps stronger bones, different eyesight adapted to red light, new biological changes caused by generations living beneath another star. Given enough time, they may become something humanity has never seen before. Not aliens, but no longer exactly the humans who first left Earth. History has shown this before. Isolation changes populations. On another world, those changes could become even more profound. There's one lesson Proxima b teaches better than almost any other planet. The universe is not designed for us. We often imagine space waiting to be explored, waiting to be conquered. But the truth is far less comforting. Space doesn't care if we survive. Stars explode without warning. Planets lose their atmospheres. Radiation floods entire worlds. The universe isn't hostile. It's simply indifferent. If humanity wants a future among the stars, we won't find perfect worlds waiting for us. We'll have to build our own future, one challenge at a time. Perhaps the greatest value of Proxima b isn't that we'll live there. Maybe we never will. Maybe future discoveries will reveal a world too dangerous, too barren, or too unstable for permanent settlement. And that's okay. Because exploration has never been only about finding a new home. It's about understanding our place in the universe. Every mission teaches us something. Every discovery answers one question while creating 10 more. Proxima b is more than a destination. It's a symbol, a reminder that even the closest neighboring star still holds mysteries waiting to be solved. Now, before we leave, take one final look at this distant world. A planet circling a tiny red star. One hemisphere forever facing endless daylight. The other trapped in eternal darkness. Perhaps beneath its frozen surface, life quietly survives. Perhaps it never existed at all. We don't know. Not yet. But somewhere, more than 4 light years away, that world continues its silent journey around its star, unaware that an intelligent species on a small blue planet has spent decades wondering what it's like to stand there. And maybe, one day, someone finally will.
Human history has always been the story of impossible journeys. Our ancestors crossed deserts without knowing what lay beyond the horizon. They sailed across oceans. Without maps, they reached the moon. When many believed it could never be done, every generation inherited a frontier and pushed it a little farther. Today, our frontier is no longer another continent. It's another star. Will humanity ever reach Proxima b? No one can answer that today. But if history has taught us anything, it's this: the impossible has a strange habit
of becoming inevitable. Perhaps not tomorrow, perhaps not in our lifetime, but someday, the light leaving Earth tonight may illuminate the first human footsteps beneath another sun. And when that moment finally arrives, it won't just mark the beginning of a new colony. It will mark the moment humanity truly became a species of the stars. Because every great journey begins with a single question: what lies beyond the horizon? For our ancestors, the horizon was the ocean. For us, it's the stars. And somewhere beyond that crimson light, our next chapter may already be waiting. The universe is vast. Our story has only just begun. Fade to black.